This is question 14 from the mixed exercise in chapter 10 from the Pearson textbook. And so we've got to find in degrees the values of theta in this interval which satisfy this equation. So we can see we've got a mixture of coses and we've got sines in there as well. So we want to try and write it all in either coses or sines. So we're going to use the identity sine squared theta plus cos squared theta equals 1. And if we rearrange it, we can get that sine squared theta is equal to 1 minus cos squared theta. And we can use that to replace the sine squared in this equation. We're replacing it by the 1 minus cos squared theta. So if we do that, we'll get 2 cos squared theta minus cos theta minus 1 is equal to 1 minus cos squared theta. And we're just going to take everything over to the left-hand side. So we're going to add cos squared to both sides. So we're going to get 3 cos squared theta minus the cos theta we already had. And then if we take away 1, we're going to end up with minus 2 there. And that's equal to 0. And you can, if you like, then do a substitution and say, well, let x equal cos theta to rewrite this quadratic equation. And we'll get 3x squared minus x minus 2 is equal to 0. And if we put that in our calculators to solve it, what we'll end up with is x is equal to minus 2/3 and also x is equal to 1. So using those two solutions to the quadratic, they're actually values of cos theta. So we've got that cos theta is equal to minus 2/3 and the other one being cos theta equals 1. So what we're looking for is values of theta. So we need to do inverse cos for both of these. So we do inverse cos for minus 2/3. Then the calculator will give us the nearest value to 0, which is going to be 131.81. And if we put this one in, we'll get that theta is equal to cos minus 1 of 1, which is actually 0. So we need to find the values in this range. So it's always handy to draw a graph of this. So just draw a quick cos graph for this in the range. So 90, 180, 270, 360. And cos goes through 0 at 1 and then comes to 0 at 90 degrees, minus 1 at 180, 270 is back at 0, and then 360 back at 1. So if we join them up, get that. And our calculators has given us the value at 0 for cos theta equals 1. But because we are only interested in values of theta that are greater than 0, we can reject that one. And also the other value that is in the range up to 360 is actually at 360, so it equals 360. So we could reject that value as well. So we can reject this one because it's not in our range. So we're only interested in this one, and that's given us this solution here, approximately, which is minus 2/3, and that's for 131.81. And so we can find the other solution because it's symmetrical, this graph. We can take away 131.81, we can take it away from the 360, and that will give us 228.18. So that's the other solution there. So 228.18, and not forgetting that we've got to give our answers to one decimal place. So that gives us 131.8 degrees and 228.2 degrees. And that's it. There are solutions.